Welcome to Digital Toolbox. In this tutorial we're going to go over implementing a very basic definition for louvers on a cladding. So here we have a simple wall that we've created and in Rhino, and now we're going to apply different louvers that we can toggle the number of louvers, the orientation, and the cross section, as well as the height. So these louvers are in Rhino are going to be defined in Grasshopper, and then our original geometry here in Rhino. So we'll pop open Grasshopper, and you can see what's going on here. We have these three kind of individual definitions, all for those three claddings. So I'll go ahead and delete these two and zoom into this one right here. So this is it. It's a few simple buttons, and I'll just go ahead and delete the meat of it so we can walk through it. So it's going to start out with a curve, which in Rhino will be the base of our cladding. So in our wall right here, I've exploded the curves from this opening, so I can get this curve down here, and that'll be the base curve. So let me go ahead and set that right now. Set one curve and click on that curve, and there we go. So that's set, and now our cladding will be derived from that. I also have a few sliders here. One's from like 5 to 30 or so, and that'll be the divisions for the number of louvers that we'll have, the number of members. And then the cross section will be defined by these two. Right now it's a 2x4, and these will have to be reduced down to inches, but that'll be our basic cross section of our member. And then the height will be the span of the opening we have right here. So very simply, we just go under curve, division, and divide curve. And here we'll just connect C back to curve, and then N is going to ask for the number of segments, so we'll drop that back to our division 17. So you can see here that as I toggle the number of divisions, the number of points repopulates on that curve. So that's the main function of the divide curve. Those are equal length segments. So now on those points, we're going to generate a box. So under surface primitive, go to interval box, and this gives us a box based on B, which is going to be our base plane, which is just 0, 0, 0 to begin with. And then we're going to put that base plane on each of these individual points. So you can see here that it's generating these 1 by 1 by 1 boxes on each of those points. So 1 by 1 by 1 is defined locally in these numbers x, in x, y, and z right here. So we'll just go ahead and take these back to our individual sliders. So the height is going to be 9 feet, but we can toggle that to whatever we want. And then the width, the cross section is going to be a 2x4, which will be the x and the y. But right now, since our project is in feet units, we're going to have to reduce this down. So I'll go under scalar, or scalar, and get a f1 function, a single variable function. It's under logic. Grab that and drop that down here, and then I can double click on it and edit the expression. So in the expression editor, I'll just do x divided by 12, and this will drop us back down to inch units. So then we just drop in our 2 and our 4 into these into the function, and you can see it's already reducing down that 2 and now the 4. So now we have a 2x4 cross section divided 14 times along this curve, and with a height of whatever we specify. So we can go back and change the cross section of the board as well as in either direction, as well as the height and the number of divisions on that curve. So once you create a basic definition like this, but you have many individual uses for it, then we can just go and copy this and set it to other curves too. So this new one, we've just copied. We'll set this one curve to this middle opening right here, and this could be very different from your original opening that you did, but now you've taken the time to create that one basic definition that can apply to any number of curves. So it's just a simple type of workflow to maximize the potential of Grasshopper with Rhino.